Okay, is everybody in? Okay. All right, welcome everyone to BC Calculus. I'm looking forward to teaching you guys this year. I've taught BC before, but I haven't taught BC in like 5 or 6 years. So I'm excited to be able to have the opportunity to teach you guys. I have all AP Calculus classes this year. So I have BC classes 2nd and 3rd period. All the other periods are AB. I don't have a planning period, but at least they're not giving me an advisement roster. So I do have that 30 minutes as my planning period. So it'll be a busy year, but I'm still excited and looking forward to it. Okay, so you guys sign up for Text Remind. Okay, now if you guys can do this for me, I feel like from my experience with BC students is that we're gonna go fast, but you guys are pretty self-sufficient, and you guys, from my recollection, just students are able to do a lot of the work on their own as long as they have good resources. Okay, so I really want to provide as much good resources as I can that you need to be successful in this class. Not saying that I'm not available for help sessions, but I feel like all students are able to kind of manage their own time through their work. I'm still going to check homework daily, but I want to just make sure that you guys know where the resources are. So if you guys can go to my my website here, mryangteacher.weebly.com. Just you can pull it up on your phone, and you're going to click on the BC tab, and that'll take you to your homepage. I have class notes and videos, which is where the link for all the units that we're going to cover. I have calendar on the homepage. I have the syllabus on the homepage. I also have some online resources from other websites that I find are helpful and are good. Okay. Now we're going to jump directly into limits today. So if you guys can go to Calc BC, class notes, BC Unit 1 limits. Okay, so once you're on the limits page, at the very top is the link to your textbook exercise problems. Now, I gave you a printout of the textbook exercise problems for chapter 1. It's all coming out of this textbook. Now, this textbook is not ready, had not come into our school yet, so it's not ready for students to pick up. But I feel like with all the notes and everything that I'm providing for you, I think a lot of times you're probably not going to need this textbook, but some students do want a textbook just to have as a resource at home. You shouldn't have to, bring it to class every day. But once it's available, I'll let you know, and then we'll go down to the media center and we'll have students pick up the textbook to just leave at home if you want one. Okay, but for now, I think we're good with the notes, with the guided notes, and with the exercise problems that I printed out for you guys. But if you misplaced your exercise problems from the textbook, you can always click on these links, and that will take you to those pages. Okay. The updated calendar will be at the top of every units page. Today we are starting with rates of change, defining limits. So I have the student packets, the notes packet for you guys that you guys picked up. But if you're missing it, or for some reason you want to get to the individual pages, you can click on that link. I have the key for all the notes. So if you miss a day, or if you're coming late, and if you want to copy the notes, you can always click on that key. Video, I'll be recording every day, and I will upload it to my website at the end of each day. So if you miss a day for some reason, or if you want to rewatch the video, I'll have the video for you to access. Okay. And then also have solutions for all the homework that I'm going to assign. So that will be available as well. Now, something that I want to point out here is in your limits packet, okay, if you go to page 18, I have some of the homework problems in the packet. Okay, so what happened? The nice thing about this textbook is that at the end of every exercise problems, there's always an AP problems, multiple choice problems that's associated with that unit. So it's in the, but I felt like it may be good just to have these on a separate page so you can kind of work it through with all the multiple choice. So I think I suggest that for the other homework problems, you can do it on a separate page. But when you get to the AP problems, you can just do it on this. And so on a daily basis, I'll be coming around and checking your homework as well as your AP pages assigned or AP problems assigned. Okay, so but they will all be available for you to click on as you do your homework and checking your answers. Okay. All right, so this is highlight from your class syllabus that you picked up. We have 3. This hasn't changed. The grading scale hasn't changed. We have major category, a minor category, and a practice category. So typically, we're going to have quizzes before tests, but at the pace that we're going, sometimes for a smaller unit, I may just have a quiz, or maybe even for some units, I may just jump directly to a test without a quiz, just depending on the unit. And as far as homework goes, I'll be checking that on a daily basis, starting tomorrow. Okay, so tomorrow I'll be checking your first day's homework. I'm just so homework. So let's see. No, all test books will be closed notes. No final exam this semester, but I am going to try to do like a mock AB exam, just as for like a practice grade, right? So there's no final exam. Homework will be assigned and checked daily. So here's the daily routine. I'll be coming around and checking that you completed your homework. Okay, so I want to see your work. I want to see your steps. I want to see corrections that you made after checking with the key. And writing down just the problems and answers is typically not sufficient. Now, there are some problems where there's not much to do except to write the answers, which is fine. But for the most part, I care more about your work than your answers. Okay, so I just want to see that you're putting in, that you're going through the process of showing your work. Typically on, I don't have time to go over homework problems, but maybe at the beginning of class, I will highlight a few homework problems that I find are more challenging than others. It's a new textbook with new problems, so I spent some of summer just working through the homework problems, and I try to be as detailed as possible. So when you are checking with the key, hopefully that will answer your questions. But if not, you're more than welcome to ask questions in class or before school. I'm typically available after 7:30 in the morning. Now, each homework assignment will be worth 4 points. Any late homework shown to me before the next assessment will earn 3 points per assignment. So if you are late with the homework, there's no big deal. You'll still earn 3 out of 4 points. But if you're doing your homework consistently on a daily basis, then if you miss 1 or 2 here, and then you get a late homework grade, it's really not going to affect your grade that much. I mean, it's only 10% of your grade, but if you do your homework every day, I mean, those are easy points to earn. Okay. So tomorrow, when you come to class, I will have assigned seats. So I will have the assigned seats on the board here. You're going to find your seat, and then the number that's associated with that's on your desk is going to be the number that you're going to put your phone in. Okay. Okay, recovery students will have the opportunity to recover each test grade up to 75. help sessions in the morning. I'll typically, okay, so I got to figure out the schedule between AB and BC. I do want to have help sessions for you guys the day of the test or quiz. I am in the process of kind of building these test reviews for this class. But just to let you know, I'm not going to have as many test reviews as I had for AB. So AB, I would have a test review, 1, 2, and then even a morning review. So I may not have as much for you, but I can at least give you at least one test review. And usually on the test day, I will have a help session in the morning. If I don't have an additional test review, then we can just go over the test review that you've already done, or if there's any questions from your homework, we can go over those. Okay. But if there is a conflict with A/B test also on the same day, then typically I will have a help session for you guys the day before. Okay, the day before. But I will always have a help session for you guys day of the test or day before a test or a quiz. Okay. If I have any help sessions, I will record and I will upload them to our website. So if you just find the corresponding day on my website, you'll have the links that are recorded on that day. Textbooks, again, when it comes in, we can, I'll let you guys know, we can pick them up. Okay, so a must for this class is a graphing calculator. So it doesn't matter what PI that you have, but if you can get a Texas Instrument, that would be great. Either 83 or 84. There's all these different variations of 83 to 84. So any of them will do. But they all do the things that we need for this class. So it really just depends on if you want, more or less of the bells and whistles, which we don't really need. But yeah, hopefully you get your hands on them. They say that the 36 Pro is not allowed on the AP exam, but if they don't say anything, then I see students, they use it, but you'll get to use graphing if you want. If it's a calculator active test or quiz, then you can have multiple calculators. You have a 36 Pro and 84 Plus. So I'm not going to be picky about which calculators you use, but I do really want you guys to be comfortable with all the features of graphing calculators so that you're not looking for for what you need to do, or being unfamiliar with it and struggling to key in the entry on the test or quiz on AP exam. The rest are just suggestions in terms of whatever works for you with this class. I'm gonna have guided notes, but sometimes the notes do not provide enough room to do all the work that you want to do. So if you don't have printer paper or extra paper, I always have them here. So on this shelf or also on that shelf. So you're more than welcome to grab one if you need additional space to work out the problems that I'm not providing for you on the guided notes. Okay. Any writing utensil will do. It doesn't matter if it's pencil or pen. So whatever works for you, those are just suggestions if you want to have those in class. Okay, so I'm going to arrange the topics this way. The way that the book or the way that AP organizes their units, they have BC topics sprinkled throughout fall semester, but I want us to be able to have all the AP topics under our belt before spring semester, so that I can kind of give you those practice AP exams. So first semester, I'm just going to do AP topics. Okay, so if you've taken AP Calculus, AP before in the past, then this first semester will just feel like review. Okay, second semester, I will do all the BC topics. So there's a couple of miscellaneous topics that are in chapter 6 through 8. So we'll pick those out. We'll do those first. And then the next unit, parametric, polar, vector, Valley functions. That's a major BC topic. And then we'll finish off with infinite series. And we should get through all this by mid-March. And that way it'll give us a good month and a half, if not more, to prepare for the AP exam. Now, in the past, the AP exam has been, as early as the first few days of May. But this year, because of the way the calendar works, they're not going to start AP exam until the second week of May. So we're not going to have our AP exam until the third week of May. So it's good in that. It's, you know, it's good in the sense that we have more time to prepare for the AP exam. But it's also bad in the sense that it extends your school year another week, essentially, because the first week of May, the Monday doesn't start. The Monday is the last day of April, so that's why they pushed all the AP schedule back. So this is the second week of AP testing, and May 13th is going to be our BC exam. Okay, for those of you who don't know, if you're taking the AB exam, the BC exam will be pretty much the exact same format. Obviously, there's AB topics and BC topics on the BC exam, but there's going to be some emphasis on the BC topics. So you're going to start off with 45 questions, multiple choice, split between calculator and non-calculator. And then you have a break, and then you'll come back and you'll do 6 FRQ problems. Now, you're going to have 3 problems that's dedicated for BC, and then the other 3 problems you're going to share with the AB test. But the first 2 problems will be calculator permitted, and then you'll be asked to put away your calculator, and then the last 4 problems, the last hour of your exam will be 4 problems with no calculator. So typically, give or take, you'll probably spend around 15 minutes each FRQ problem. Okay, so these are the big ideas for calculus. Now this is actually up in the slide for AB. So we're going to cover derivatives first, and then the second half of the first semester we'll do definite integrals. Look, we're going to start off with derivatives. It basically describes the rate of change of one variable with respect to another. So in other words, we're going to start off with slope. Slope is just derivatives, the fancy word for slope. And then we're going to undo that process and talk about definite integrals, which is the net change of one variable over an interval of another. In other words, changes related to area. So slope and area are just inverse process of each other. And we'll cover both these big ideas first semester, and then second semester will be our BC topics. Okay, so again, assign seats tomorrow, and then you'll put your phone in the phone cubby. Okay, but we're going to start off with notes for limits. We're going to jump right into notes. Any questions that you guys have for me? Okay, let me go over the calendar real quick here. Today we're going to try to cover all of 1.1, maybe dig into 1.2 a little bit. And then your homework, it's going to be page 85, 89, which is in your chapter 1 homework packet. So I have all of chapter 1 in here. So 85 to 89, 25 to 41 odds, 37 and 41. And there's AP practice also in here, but again, it's also in your packet. I think I try to space it out so that you guys can have room with multiple choice questions. So, but if you choose not to do that, that's fine. You can do it all on a separate sheet. But just to let you know, all the AP practice are going to be in your packet. Okay. So we'll cover. There's not going to be a quiz for this unit, so we're going to cover all of chapter 1 this week, and then we'll have 2 days of review. Now, I know we're kind of, we're going at a pretty fast pace, so I think the way that I'm going to kind of buy you guys a little bit of time to study is before a test, I'm going to start the next unit. Okay, so that way it kind of gives you an extra day to review, but then I also don't lose a day of instruction. Okay, so typically I want to do that, just kind of give you an extra day of review. But obviously, once I start chapter 2, it's not going to be on the chapter 1 test, but it just gives us a way to kind of move ahead, but also give you some additional time on your own to study. Okay, so our first test will be next Thursday. Okay, yeah, I wouldn't say that the AP the BC test is any harder than the AB test. I'll just say that we're going at a faster rate, so we're cramming more material in a shorter amount of time. But if you did well in AB, you should do well in BC as well. I mean, as long as you are keeping up with the work and that you're not falling behind and you're not forgetting what we've covered in the past, it should feel very manageable. Okay. Okay. All right. So let's go into our okay, so the first page, I just have some steps for important concepts. I will highlight those as we get to them. Okay, so go ahead and read number 1. All right, Mr. Brutt's distance from his house is modeled by a function d of t. So you see the curve here, that's your d of t function. While riding his bike to the store, he realized he dropped his wallet and turns around to find it. After finding his wallet, he finishes his ride to the store. What is his average speed, his average rate of change for his trip to the store if he arrives after 8 minutes? So anytime we see average rate of change, there's no calculus involved. We're just finding slope. So if we can just find the order pairs, then we can just do change in distance over change in time. So 8 minutes in, he's 1,300 meters away from where he started. And then he starts off at time 0 and location 0. Okay, so for now, if you want to use your calculators, you can, or you can just kind of follow what I have on my notes. Change in position over change in time. This gives us a rate, and his average rate of change, his average speed is 162.5 meters per minute. Okay, it doesn't mean that he's always traveling at that rate, but all we care about is how much distance he covered over the amount of time that he covers that in. Okay, what was his average rate of change between 2 and 6 minutes? Same idea, we just find his location at 2 and 6 minutes. And whatever that gives us, that's our rate of change. I didn't do the work here, I just set it up. Okay, next up, is it possible to know how fast he is going at an instant? So if we want to find his exact slope or exact rate of change, speed at a specific moment, we can do that, but right now with just slope, we need 2 points, right? So we need 2 points. We can maybe find a really good approximation. If we just pick 2 points really close to each other, we can get a pretty good idea of his rate of change. We call that the instantaneous rate of change. Being able to find the exact, in this case, speed at a specific moment in time. For B, it's just asking for the average rate of change between 2 and 6 minutes. So, we can just read the graph here. So, yeah, right. So, we can estimate it maybe like 1100 or 1000, right? Okay. But that's the best we can do with the limited amount of information that we have. So we're going to kind of get to this idea of that if we pick points really, really close to each other, we can get a pretty good approximation of that slope of that tangent line. But it's still not perfect, right? Because it's still going to be a little off because we're still an estimation. But calculus is going to is eventually going to allow us to make that jump. But right now, the best we can do, if we want to find a really good approximation or get close to that instantaneous rate of change, we'll just have to pick points really, really close to each other. Okay. So if I find the distance at 2 minutes and find the distance at 1.999 minutes, obviously the more decimals you include, the better approximation is. But still, no matter how many approximations or how many decimal places you go to, it's still an approximation. And give a rough estimate of the instantaneous rate of change at t equals 2. So I just chose 2 points that are really close to each other, and a good estimation could be 150 meters per minute. Nope. Oh, sorry. Yeah, let me switch this out. Thanks. Okay, let's just do another example of rate of change, and then we'll go into limits. Number 2 says B of T represents the buffalo population in the US, where T is measured in years since 1800. So what does B of 90 represent?
Buffalo population in 1890.
Yeah, so 90 years after year 0. So in this case, year 0 is 1800. So year 90 will be 90 years after that. So then part B, what do you think that represents? B of 50 minus B of 0 over 50 minus 0. What does that represent?
The average rate of change from 1800 to 1850.
Right, so the change in the buffalo over the 50 years, over that 50-year, the change in buffalo population over that 50-year period. And what is part C? What is that trying to do? Not exact, but what is it trying to approximate for us? Yeah, so it's trying to do a good estimation of the exact rate of change of the buffalo population in year 1832. Change in population per year. But you see that 31.999 is trying to find 2 points really close to each other so we can get that tangent line, but obviously it's not quite perfect. But calculus is going to help us reach that point of exact instead of just approximation. But it's kind of leading us to that, right? It's the idea that, okay, we're going to take the slope concept and we're going to find a way to get to that instantaneous rate of change, but we're going to need the help of limits, which we're going to cover this next unit. Okay, number 3 is just more of the same. I'm going to have you guys try that on your own later. Let's go into our notes for limits. Okay, so here's the definition for limits. Limit is the y value. Okay, so anytime we're asking for limit, we're always asking about something that is related to the y value. That a function or graph approaches as the x value moves closer towards that given constant. So it's related to order pair, but it's also slightly different. Okay, so let me talk about, we'll compare those instances in a second. Function value, however, is finding the location of the exact y value at that specific x value. So it's basically just finding the point. But limit is talking about the approach. So let's see the comparisons between order pair and limits with these next examples. So let's start with something easy here. F of 2 is asking for the y value. What's f of 2 equal to? 1. Okay, so I'm going to highlight that point here. F of 2 equals 1. Now, limit as x approaches 2 is the same idea, but it's asking about the approach. So what I'm going to have us do for now is it's asking, is the graph approaching the same y value from both sides of 2? So I'm going to pick points on either side of 2. Doesn't matter where, just pick relatively close. I'm going to draw an arrow along the path of the graph. Okay, so I think this is a good visual exercise here. Both arrows, are they headed towards the same location? Yes. Okay. We don't care if they actually arrive at the location. We just care if they're approaching the same location. They are, and they're both headed towards a y value of what? 1. So that is the difference. Okay. So even if the graph doesn't exist at that order pair, as long as the arrows are pointing to the same direction, pointing to the same location, that's your limit. If x is less than 0, we don't really have to worry about that because we just care about what is the graph doing as it gets closer towards 2. So if we're too far away from 2, then we're too far away from this problem. Okay. So I'm going to write this here. As x approaches 2, the y value approaches 1. Okay, so we're gonna see this very similar graphs, these next two here. Okay, here for this graph, very similar here, but f of 2 is what? Do you see anything at f of 2? Undefined, right? There's a hole there, but that hole is, we don't have the point defined anywhere else, so we say this is undefined. Or if you say D and E for does not exist, that's fine as well. Either is fine as long as you can indicate that the point is not defined there. Now, limit as x approaches 2. So we care about what's happening around 2. So again, I'm going to pick points on either side of 2. I'm going to draw an arrow towards 2. Are the arrows pointing to the same location? Yes, they're both pointing towards a y value of what? 1. So the limit does exist even though the point doesn't exist because we don't care about the point. We care about the arrows. Okay, as long as both arrows are pointing to the same location, that's good enough for a limit to exist. But it's got to be from both sides. Okay, try this next one on your own and see if you can make progress there. Right, in this case, f of 2 equals 3. But the limit as x approaches 2 is what? Still 1, right? Still 1. So here's a big thing that we're going to discover is that if there is no breaks in the graph is continuous. Okay? If there are no breaks in the graph, there's no holes, there's no asymptotes. You're not going to be able to distinguish between limits and order pair. They're always going to be nicely consistent. Only when there's a break in the graph, like a hole or a point defined elsewhere, then you're going to see very distinct differences between order pair limits. Okay, you should be expecting different things from your order pairs and limits. But if the graph is continuous, you're always going to get a consistently the same answer. Okay. We're going to talk about continuity in the next day or two, and that's going to be something that we're going to use to help us define continuity versus a graph that's not continuous. Okay, so any questions? All right, so you can try these here. These just this is use the following graph to evaluate each problem. See if you're able to go through the process that we learned. Order pair is just the point. Limit, you gotta look for points on either side and convince yourself that both sides are approaching the same y value. If they're not approaching the same y value, then we say the limit does not exist. Okay. We'll compare our answers in a bit. As you're hopefully discovering, if there's no holes in the graph, there's no breaks in the graph, your limits is like finding your order pair. Okay, you're just not going to have any distinction between them. Only if you see a hole or break, then you're going to be expecting some distinctions between your order pair and your limits. Okay, so let's check our answers. Okay, any questions, or are there any ones you want me to go over specifically with you? All right, next one. It says, number 9 says, give an interpretation of the statement. So the way that we say this is, as x approaches 7, f of x approaches 10. Or limit as x approaches 7 of f of x equals 10. So the key word there is approach. We don't care about, it's possible that the order pair lives at order pair 7, 10, but this statement just guarantees that the graph is headed towards a y value of 10 for both sides, but it doesn't guarantee that the order pair is going to live there. It's possible, but it's only the limit that exists here. Okay. A limit does not tell us the value of f of x. It just tells us what the function approaches. So true or false? F of 1 equals the limit as x approaches 1 of f of x in all cases.
False.
False. Okay. Next statement. True or false? F of 1 is never equal to the limit as x approaches 1 of f of x in all cases.
False.
Also false. Okay. So here are some cases that counters these statements. It's possible that the order pair doesn't live where the limit exists, right? That the graph will look like this. But it's also possible that the order pair and the limit do agree. If they agree, it'll look like this. It'll be continuous. So if your order pair and your limit are one and the same, your graph will be connected through that point. You're not going to see any breaks or holes if they are in agreement. Okay, so let's see how much we can get through of pages 4 and 5 on our own, and then I will show the answers as you guys get to them, and I'll walk around, see how we do. And I want to save the last 5 minutes of class, or last few minutes of class, just for you to show me on your phone that you can get to the chapter P page, or sorry, the chapter 1 page on my website, just so I can know that, okay, you know where to go for all the keys and solutions and videos.
Yeah.
Okay, a few minutes left in the class. Hopefully you guys all know where to go for your homework. I'll send you guys a link to the BC page. But if you guys can do this for me right now, can you, on your phone, just pull up this page so I know that you can get to this page? So mryangteacher.weebly.com, click on the BC link, go to the chapter 1 page. And just show me you can get there.
If we were like the next day, when I. But in.
The end of second. Going. Oh, I think you know the problem is that's not going to the problem.
Something to help.
It's gonna be a while. It's really good.
Twenty-five to 41 pods, 37.
Oh, 25 to 40. Wait, so.
Yeah, probably doesn't.
You like say. Yeah. Thank you now. It's all the gear, but I should mix it up.
Yeah.
Dude, like this exactly. It's equal to like 8.
Have a great day, guys. Good advisements.
I was wondering if I could help with grading since you're so busy for the AB classes, and some of the tests and stuff.
I have a teaching assistant for AB, but yeah, thanks for the offer. I
Okay.
think I'll be good, but I may take you up on it if you're free. Future down the line, but thanks for offering.
All right.
Appreciate it. All right. Have a great day.
You too.
Hey.
Yeah.
See you guys. Good. Here's the last thing. This is probably what we got. Last thing.
Climbs a lot, so don't like colleges.
Oh, yeah.
I have a question about,
Yeah, email me and then, I'll get up with one. I don't know how you're gonna do that, but yeah, email me and then.
I think I sent one to you.
I'll say like, try to send it through my personal and my home.
There were, yeah, either one, but Yang D and Focus Sports.
Thank you.
Okay, take care. Good seeing you. Have a great year. Oh, yeah, will you be in my class or?
No.
Oh, you're not
staying in stats.
You're saying that's good, no problem. Okay, see ya.
Yeah.